Kia ora everybody in the physics classes, and one of them is actually looking on here. This is page 110, question 2, and I'm doing this little outline from the 11th of March. This tough question threw a couple of people in my class, and when Mr. Kumar's class, who's in front of me now, gets to it, could throw them too. So what I thought I'd do is make a little video about it. The situation is this: we have a rod with a small ball one end, heavy ball the other. It's 0.2 kgs that end, 0.3 kgs that end, and in physics jargon, the rod is very light. In other words, there's no mass at all. You can ignore it. And it's 0.2 meters long from the center to the center. And C/C is the builder's jargon for center to center. The rotational inertia, we have to find about the center, I equals mr squared, so we can have one from the center, mr squared plus mr squared. So we have 0.2 times 0.1 squared plus 0.3 times 0.1 squared gives us 5 thousandths, or 1/200th or something, kgs meters squared. Now, measuring it from the 0.2 kg end, we can have mr squared plus mr squared, 0.2 times 0, because from the 0.2 kg end, the radius is 0. The other end is 0.3 times 0.2 squared, so we get 0.012. From the rod will rotate about its center of mass if you chuck it up in the air, because that's what they do. That's the definition of a center of mass, actually. And going back to our center of mass stuff, which I think Mr. Kumar's class here in front of me would remember. We got that formula, put some numbers in from the 0.2 kg end, 0.2 times 0 plus 0.3 times 2, all divided by 2 masses, makes a half. It gives us a total of 0.12 meters from the 0.2 kg end. Does that make sense? Yes, it does. It's slightly more than halfway because the 0.2 kg end is slightly lighter. The answers in the back of the book. Do stuff with ratios. 3/5 and 2/5 times 0.2, which is a bit confusing for some folk, which is where the question to make this video came from. But if we use this method, it's easier. Now we can find the moment of inertia. 0.2 times 0.12 squared from one end, plus 0.3 times 0.08 squared from the other, gives us that. And finally, the least rotational inertia is likely to be about the center of mass, because that's where the minimum energy is when things are spinning about the center of mass. Otherwise, it would tend to take a lower form of energy. Cool. That's enough of that. I will post this video on my YouTube channel, and you probably will see that because you'll be looking at it on that platform. Kia ora, folks.